everyone, it's me, Destroyer, and today I'm going to be reading for you the article on, apparent magnitude. Just the first section though, because I say so. Okay, let's get started now. Apparent magnitude. For a more detailed discussion of the history of the magnitude system, see magnitude astronomy. Apparent magnitude, m, is a measure of the brightness of a star, astronomical object, or other celestial objects like artificial satellites. Its value depends on its intrinsic luminosity, its distance, and any extinction of the object's light caused by interstellar dust or atmosphere along the line of sight to the observer. Unless stated otherwise, the word magnitude in astronomy usually refers to a celestial object's apparent magnitude. The magnitude scale likely dates to before the ancient Roman astronomer Claudius Ptolemy, whose star catalog popularized the system by listing stars from first magnitude to sixth magnitude. The modern scale is mathematically defined to closely match this historical system by Norman Pogson in 1856. The scale is reverse logarithmic. The brighter an object is, the lower its magnitude number. A difference in 1 corresponds to the brightness ratio of the 5 root of 100, or about 2.512. For example, a magnitude 2.0 star is 2.512 times as bright as a magnitude 3.0 star, 6.31 times as magnitude 4, and 100 times magnitude 7. The brightest astronomical objects have negative apparent magnitudes. For example, Venus at negative 4.2 or Sirius at negative 1.46. The faintest stars visible with the naked eye on the darkest night have apparent magnitudes of about plus 6.5. Though this varies depending on a person's eyesight and with the altitude and atmospheric conditions. The apparent magnitudes of known objects range from negative 26.832 to objects in Deep Hubble Space Telescope images of magnitude 31.5. The measurement of apparent magnitude is called photometry. Photometric measurements are made in the ultraviolet, visible, or infrared wavelength bands, using standard passband filters belonging to the photometric system, such as the UV system or the measurement in the V-band may be referred to as the apparent visual magnitude. Absolute magnitude is a related quantity which measures the luminosity that a celestial object emits, rather than its apparent brightness when observed, and is expressed on the same reverse logarithmic scale. Absolute magnitude is defined as the apparent magnitude that a stellar object would have if it were observed from a distance of 10 parsecs, 33 light years, or 3.1 times 10 to the 14th kilometers. Therefore, it is of greater use in stellar astrophysics since it refers to the property of the star regardless of how close it is to Earth. But in observational astronomy and popular stargazing, references to magnitude are understood to mean apparent magnitude. Amateur astronomers commonly express the darkness of the sky in terms of limiting magnitude, i.e. the apparent magnitude of the faintest star they can see with the naked eye. This can be useful as a way of monitoring the spread of light pollution. Apparent magnitude is technically a measure of the luminance, which can also be measured in photometric units such as lux.